today what we are going to discuss in microwave and optical communication laboratory, we are going to discuss directional coupler experiments. I mean directional coupler characteristics we are going to see. This is a directional coupler device. It is a microwave equipment. By using this device, so students can able to know that power value. By using this device, we can calculate power, generally power value. I mean reflected power, or otherwise a voltage standing wave ratio. We can calculate power, reflected power, standing wave ratio. Everything we can calculate by using this device. We can calculate mainly power. I mean coupling factor as well as the directivity. Very most important point, coupling factor as well as the directivity we can calculate by using directional coupler. Okay, before we are going to discuss about this microwave bench setup, I mean directional coupler characteristics, students must should know that what are the components we are going to use in this microwave bench setup. That is important. This device Kleston power supply. This device is a Kleston power supply. What is the name of this first? According to your functional block diagram, the first microwave bench setup, it is a Kleston mount with a tube. So it looks like a black color. It looks like a tube size. So this is name of the device is a Kleston mount with a tube. This is isolator. This one is a variable attenuator. This device name of the device is frequency meter. Name of this device variable attenuator. So name of this device detector mount, oscilloscope, and standing wave ratio meter. I mean shortly we used to represent SWR meter. CRO probe. Okay students, right, fine. So now we are going to discuss cooling fan is running. So we needed to keep the cooling fan very near to this Kleston mount with the tube because this is AC voltage, AC supply. So while you are doing, students, while you are going to do this experiments, so please be careful. So if you are going to keep knowingly or unknowingly, if you are going to touch, you will get shocked. So that this device, one more important point, this device always dissipate more heat energy. Because of that reason only we are keeping cooling fan near to this device. Okay. Coming to this Kleston power supply, students. So in modulation, we have to keep either AM mode or FM mode. You have to keep, students. That is first condition. Next, beam voltage should be minimum condition. Rippler voltage should be maximum condition. As well as here HT is there this option. HT means expansion. High tens. This should be a off condition initially. This is initial precautions. Okay, students. Before we are going to do directional coupler characteristics, these all are initial precautions. Okay, now I am going to switch it on. Okay, now switch it on. Initially it will show 00. After switch it on, students see next we have to switch it on HT switch. So once we switch it on the HT switch, so it will move directly to 199. I mean 200 volt. This is AC supply, so be careful. So now the voltage is to 199. Next, after that, we needed to set the beam voltage. Maybe beam voltage is we have to vary from 200 to up to 220 volt, not more than that. If you give more voltage, so devices here we have a microwave devices now. These devices is going to be get damaged. Because of that reasons, here we are going to set. There are three modes. There are three possibilities we have: 210, 250, 220. So I am going to give you 210. See here, everyone. So I am varying. See, slowly while varying here, values also will vary. See the display, every one of you. Slowly I am varying. So you also, while you are doing this experiment in your college, in your laboratory, you have to vary slowly. Then it will be very useful. If you give unknowingly, if you give more voltage, the entire microwave bench setup is going to be get damaged. Okay, students. See, slowly I am varying. 210, yes, 210, 211 I said. What is the beam voltage here now? So in your observation, in your lab record, now you have to know that the beam voltage should be 210. After that, here we have a meter selection. No, here the voltage mode is there, current mode is there, Rippler mode is there. There you have to change current mode, voltage mode into current mode. So you have to know out the current. What is the current value here? 12 milliamps. Here we have a milliamps range, so that we have to add 12 milliamps. After that, current mode into Rippler mode we have to change. So we change the current mode into Rippler mode. So now what is the value of Rippler? What is the value of Rippler voltage to minus 279 holes we have to note down in your observation or otherwise in your lab records. So now initial setup is over. Okay students, now we are going to switch it on. See in this micro bench setup, first device, the name of the first device is, see here, the name of the first device, Cliston mount, Cliston mount with tube. This device which is used to transfer the power from Cliston mount with rectangular waveguide. Here next device, what is next device? Isolator. What is the function of this isolator, which is used to transmit the signal only one direction? It will allow the signal only one direction. So it acts as a unidirectional device. Next, what is the device? We have variable attenuator. So normally what is the function of using attenuator? It will control the power. It will control the power whenever power level is exceeding the limit. With the help of this variable attenuator, this entire device is going to be, what is that? Get safety image. So if you want to keep this, you see, this particular device, it will operate as a production device. It will protect the entire microwave bench setup. Okay. Next, coming to this next device, what is the name of this device? Frequency meter. With the help of this frequency meter, students can able to calculate the value of cutoff frequency. Okay, right. Next device. What is the next device in the micro bench setup? Slaughter line section. So by using this device, so whenever impedance mismatching will happen, when the power signal is transferred from one end to another end, whenever any impedance mismatching will happen, with the help of this device, students can able to calculate directly reflection coefficient. They may able to calculate by using this scale. Okay. So at last we have detector mount. What is the name of this device? Detector mount. What is the main function of this device? Which is used to terminate the entire microwave bench setup. Here only students are going to connect the CRO probe. So here only you have to connect the probe terminal from here to CRO. This is initial connectivity about total microwave bench setup, students. Okay. Okay. So okay, students, now we are going to vary. We need students. You have to see carefully on the display. Here we are getting Rippler voltage. By using this option, Rippler voltage mode, so you need to vary the connection anti-clockwise. You need to do anti-clockwise direction. Slowly you can decrement the power supply. And meanwhile, you have to see the oscilloscope. On the oscilloscope, you are getting the waveform or not. We need to see. See here, see the display. Slowly, I am decrementing the power supply. Rippler voltage. So meanwhile, based on this corresponding Rippler voltage, we need to get the, see the CRO here. Please see the CRO. See the CRO here. Slowly I am decrementing. So starting point, this is, we need to find the starting point. In starting point we are getting here minus 290. Slowly I am decrementing the Rippler voltage. Decrementing the Rippler voltage. So we need to keep maximum position on the CRO. Okay. So we need to keep before we are going to calculate the power by using this SWR meter, we need to keep maximum position. Now we set it at the maximum position. Then we have to use the CRO probe. From CRO the display, now what is the Rippler voltage here? Minus 220 is there. So while we are decrementing the Rippler voltage, we need to see in the CRO, students, you have to observe the CRO on CRO. While decrementing, see here, we need to identify starting point, maximum point and the ending point. See starting point, which point the signal is going to get? Minus 220 we are getting. See, signal is starting. See the screen, everyone of you is screen on CRO. On CRO we are getting the waveform. Yes or no? Slowly signal is getting maximum. So we need to identify the maximum point. At minus 212, you are getting maximum point. Again, I keep on decrementing the Rippler voltage. Signal is going to get a decrementing. So the DC line, it's coming a DC line. Yes or no? This is ending point. So this we identified now starting point, maximum point, and the ending point. Yes or no? So ending point minus 203, we are getting ending point. So here again I am going back. We needed to keep. So for calculating the power, students, we needed to keep the power. Amplitude should be in the maximum position on the CR. So we needed to keep in the maximum position. After setting the maximum position, then you have to review the CRO from CRO device. The same. So no need to change anything in the SWR meter. So I'm going to connect. So the CRO, see from CRO probe, I removed from the CRO probe from a CRO device. Now simply I connected into SWR meter. On SWR meter, it's showing power value. Here in the power display, minus 1.20 dB is showing this value, and here we have 60. So it is showing 60. It is nearly to 60. This 60 value, this display, what we have 1.20 is there. we need to add these two values. So 60 plus 1.20, 61.20. Okay, that is the value of without directional coupler. So here up to now we are not at all connected any directional coupler. Without directional coupler, what is the power we are getting? 61.20 decibel we are getting. Okay, this is nothing but P1 value. Next, we are going to use this device. We need to connect the device across output section. Then we need to connect. We need to calculate the value of power P2, P3, and P4. That we will discuss. See how I am going to remove. So before we are going to connect the device, see we need to remove the detector mount. See I am removing the detector mount. Yes, you have to do like this. Bottom also we have a stand. Okay, slowly you have to do removal of this detector mount waveguide. Okay, see here. So after slaughter line section, we need to connect the directional coupler device. Calculate students, very important. After connection, first you need to keep the position like this. So here you have to keep whether it is this port is horizontal position or vertical position, that you have to identify. Same in this directional coupler also we need to keep whether it is horizontal position or vertical position, like that we need to identify. So it is already horizontal position, so that I am going to connect horizontally. See, if you see first the actual position like this. Okay, so this is port 1, this is port 2, this is port 3 first. So our students, you have to identify this is port 1, this is port 2, this is port 3. So this directional coupler, how many number of ports we have? There are 3 ports are available, port 1, port 2, port 3. First we need to connect port P1, and P1 should be connected. P2 should be, P2 should be output. P3 should be disconnected. Next, P1 should be connected, P2 should be terminated, and P3 should be output. Next, we need to do reverse connection. I mean, P2 should be connected, P1 should be terminated, and P3 should be output power. So this is the way we need to do connection in this micro bench setup. Directional coupler is connected, students. See this micro bench setup. So this is P1 port, this is P2 port. So here P3 is terminated. So in P2 I connected oscilloscope. Okay, see the connection properly, every one of you. From oscilloscope, where it is going, oscilloscope, I mean detector mount to SWR meter. Now what is the power we have? So here in the display we are getting minus 7.40. These two values we need to add. So 60 plus 7, 67.80 you have to note down. This is P2 value. Now we made setup. Okay, this is a directional coupler. We connected, P1 is connected. P2 also be connected with the SWR meter, and P3 is terminated. Okay, students. So where is P2 is connected through detector mode. We connected into SWR meter. See the display now. We connected. What is the power is generating? Minus 7.80 we are getting. Where is the no bit is touched with 60. So this value and the display value, both value you need to add together. So minus 7.80 plus 60, 67.80 dB. This is P2 value, students. So P2 value now we calculated. So already P1 we calculated, now P2 value calculated. Now we are going to calculate the value of P. So see now connection. So already we find the value of P1, P2. Now we are going to calculate the value of P3. See in different modes. See here now connection P1 is connected, P2 is terminated, P3 is connected with the output port. See the oscilloscope probe where it is going. It is going to from detector mount to SWR meter. So what is the power now? You see everyone carefully on the display. Minus 8.50 is there. It is displayed. So where is the knob actually? 60 dB. You need to add these two values. So 60 plus minus 8.50. So minus 68.50 dB is the power value. I mean P3 value. So like that, one more value we needed to calculate. So next value, how we needed to do? We needed to do the reverse direction. Directional coupler, it acts as a unidirectional device as well as it is bidirectional device. So that we can do reverse connection. So P2 terminal need to come here, P1 terminal need to go here, and P3 like that it will come. So I will show you that. The connectivity will change. So P1 to be terminated, P2 is connected, and P3 is output. It is connected from through detector mode. It is connected to SWR meter. See the SWR meter on the screen. So it is getting minus 8.50 dB is coming. See
minus 8.50, I mean 7.60, initially 7.60 we are getting 7.60. So that value plus this, what is it, this node where it is going to be touched, that particular value, those two values are we are going to add together. For example, here we are getting minus 8.50 dB as this value and this value we need to add together. So if you're going to add these two values, 60 plus 8.50, you will get minus 68.50 dB we will get. So this is nothing but a P4 value. Okay, when it is in the directional coupler in the reverse direction also we are getting the power. So by using finally students in your curriculum, what you are going to calculate by using this directional coupler, 3-port directional coupler, you are going to calculate the value of coupling factor as well as directivity. So both parameter you are going to, both characteristics you are going to calculate with the help of this device. Okay students, thank you for